Hi everyone, it's Mrs. Bebo. In this video, we're going to be covering lesson 1.4, which is all about the graphs of proportional relationships. Our learning targets for this video are how to identify a proportional relationship from a graph. And then in a part 2 of this video series, we'll do a how do I find the constant of proportionality from a graph, and we'll focus on that. The only vocab is constant of proportionality. In a previous video, we talked about this when we did tables of proportional relationships. Same definition as before. Two quantities are in a proportional relationship if they have this constant ratio between them. And this constant ratio is actually called the constant of proportionality, which we use the variable k to represent. This has the same value as the unit rate, and just as a heads up, it's also known as slope. So when you get to pre-algebra and algebra 1, you're going to be using the variable m to represent slope, which again is just this constant ratio that is showing up within a linear equation. So how can we tell if the relationship is proportional based on the graph? Well, a graph shows a proportional relationship if it is a straight line through the origin. So if I take a look at this example on the left-hand side, we can see that it's starting in the corner of our first quadrant of the coordinate plane. It's starting at 0, 0, and then increasing from there. And it's a nice straight line, and it goes through the origin. A graph is going to be considered non-proportional if it's not a straight line, or it's a straight line like we're seeing here in this example, but it doesn't pass through the origin. So for the proportional relationship, it has to be a straight line through the origin, and anything else that doesn't meet that criteria is going to be considered non-proportional. So we're just going to go through some quick examples. So taking a look at this first one, we have a graph, and we want to check for things of 1, is it a straight line? And then 2, does it go through the origin? So those two things we're going to want to check for. So is this relationship that is showing a relationship between force and exertion a proportional, non-proportional relationship? So if I take a look, it's going through the origin, so that passes that check, and then it is a straight line. So this is going to be considered a proportional relationship. All right, next example. So again, checking for those same things. Does it pass through the origin, which immediately we can see, no, it does not. The line is definitely starting above that mark, but it is a straight line. But because it doesn't go through the origin, this is going to be considered non-proportional. All right, this next one. It does start at 0, 0. But is this a straight line? Nope, it definitely curves. So because it's not a straight line, and even though, yeah, it's going through the origin, because it's not a straight line, we're going to say it's non-proportional. All right, with this next one, again, we're checking for those same characteristics. Does it start at 0, 0? Yep. Is it a straight line? Yep. That means it is proportional. So why does the line of the graph of a proportional relationship need to be straight and pass through the origin? Because again, proportional relationships have a constant ratio between quantities. This constant ratio is called the constant of proportionality, K. So that's where I'm going to end this video. So this video is just a really quick one, again, on quickly identifying based on the graph, is it a proportional relationship or not? In the part 2, we're going to dive into looking at actually calculating this constant of proportionality from the graph. Thanks for watching this, and make sure you check out part 2.